Hi all, welcome to Analytics School. As a data analyst, you are going to read a lot of external data sets for your data analytics project. And there are lots of different file formats to consider. For example, CSV file, Excel file, JSON files, text files, Parquet files, SAS files, PDF files, where the company stores the data. When it comes to CSV file, Pandas can import CSV file easily with the method called read_CSV. However, read_CSV has insane amount of optional parameters that can be passed into the method read_CSV. And if you think I'm exaggerating that it has insane amount of the parameters, you can look at this particular image which I have taken a screenshot from the Pandas documentation. It's pretty overwhelming, right? But do not worry, we are going to learn some of the important optional parameters. Without some of these useful optional parameters, one has to do extra pre-processing. This is usually slower and requires a higher computational cost. In short, some of these optional parameters are great time savers. So let's get started and learn how we can read CSV file in Pandas. Now we are going to see the basic way of importing CSV file in Pandas. The dataset which we are going to use is a Tableau Superstore dataset, and I have saved that particular file as superstore.csv. We are going to import that CSV file using read_CSV method. Now you can see here we have successfully read the file superstore.csv file. It is a transactional dataset which you can say it is a dataset for Walmart or Amazon, Wayfair. It can be of any retail or an e-commerce company. And this particular dataset has 9,994 records and 20 columns. The code above is the most basic way of using the method read_CSV in the Pandas library. It imports the whole CSV file. This is great. This is great if the CSV file is perfectly formatted. There are no missing values and you need all the columns and rows. However, in the real world scenarios, this is not going to be the case. And in those scenarios, we are going to use the optional parameters to handle those type of the tricky situations. When somebody is reading a CSV file in Pandas, there is a very common error comes in, and that is Unicode decode error. This error comes in when somebody has saved a file as a CSV file only and not as a CSV space UTF-8 file format. What do I mean? So you can see here, this is superstore.csv file which we have read few minutes before. If I'll open this file, you can see it is a delimiter comma and this is a dataset. And this particular file superstore.csv, it is saved as CSV space UTF-8. If I'll try to open superstore_encoding.csv file, it will throw an error to me. And the error is, it is not UTF-8 encoded. So that is an error. When we are going to read this particular file, the Python will give us a detailed error, that what is an error type is, why that error is, and then we are going to use an optional parameter to overcome this particular problem. Let's see that. So you can see here, this is an error which we are getting. The error is Unicode decode error, and the details it is providing. UTF-8 codec can't decode byte 0xA0 in position 2815, invalid starts byte. Now, what is an optional parameter is and how we can overcome this particular problem. And you can see here, by passing an optional parameter encoding equal to ISO-8859-1, and we had overcome this particular problem. Now, sometimes this does not work, so I'm just mentioning here, you can pass these to either of them. One is UTF-8, or the one which we have mentioned here. %99% of the time this will work. And you can see here we have successfully imported the data, and df underscore encoding has 9,994 records and 20 variables. Let's say you are working on a project and you have a data set which has some millions of records and has 400 columns. But for your project, you require only, let's say, 10 columns for your analysis purpose. One solution to this is to import the whole CSV file and then afterwards filter away the columns which you do not need. Let's see that. So we have a Superstore dataset which has 9,994 records and 20 columns. Out of these 20 columns, you require only 2 columns. One is customer name and sales. You want to see overall sales of a customer over the years. Now what we can do here is we can create a new data frame . Now you can see here df underscore SEL is a new data frame which has only 2 columns, customer underscore name and sales. While this approach certainly works, but it is inefficient in both code length and performance. You import the other 18 columns without ever using it. It is much better to tell the method read underscore CSV to only import the columns which you need. And one can do that by using the optional parameter use COLS. Let's see that. Now you can see here, this produces the exact same result. You avoid importing lots of the data you don't need. You avoid writing Pandas code to filter the useless columns away. But remember one thing, when we are using use calls, we generally pass a list of the columns we want to import. Generally, Pandas will parse any column with date as an object data type. However, converting it into Pandas DateTime object will unlock more functionality. We can do this after reading the data by using pd.to_datetime method. But it is more convenient to do this while reading it in the CSV. This is exactly what the parse underscore dates argument does. Let's look at an example. If you will see here, our df underscore superstore dataset d types, you can see order date and ship date. They are date fields. But Pandas has saved them as an object data type. We can easily convert them to a date field by using Pandas DateTime method. We will come back to apply method and all these methods later on. But right now I just wanted to show you how to convert the columns which are object data type to a datetime data types. Now, as expected, order date and ship date has been converted to datetime data type. Now let's read the same CSV file with parse underscore dates parameter set to order date and ship date column. Let's do that. So here I'm passing order date and ship date in parse underscore dates parameter. Let's run the code. And you can see here, in spite of we have to apply multiple steps, we are able to read order date and ship date as datetime data type. It might be useful to set one of the columns in your data frame as an index. Let's say in our case, customer ID as an index, as we want to do the analysis at customer level. One can do this by using set underscore index method after reading in your data. But you could also do it while reading the CSV file by using the index underscore column method and specifying the name of the column you want as an index. Let's do an example. You can see here I'm using the info method to find out the details about this data set df underscore superstore. You can see range index, which is a default index method when we create any data frame or we call any external data set, and it is range from 0 to 9993. Now let's say if we want to set our index as customer ID, what we can do here, we are going to use set underscore index method. And now if we will use info method, you can see here index is ranging from CG-12520 to CC-12220. So this is how you set an index once you call an external data or you create your own data frame with a default index of pandas. But you could have also done it while reading it in by using the index underscore column argument. Let's see that. And here you can see we have created a custom index. Let me show you how the data looks like. So customer ID is my index. Oftentimes Boolean values in a data set are set to yes or no, 1 or 0, or some other pair rather than true or false. In this example, we are going to see that how we can change these to true or false by using the true underscore values and false underscore values parameters respectively. Now what we are going to do is we are going to create a new data set and we will pass true underscore values parameters and false underscore parameters. Let's say the Boolean values are saved either as yes, all lowercase, or all uppercase. Similarly for false underscore values, all lowercase or all uppercase, yes or no values. Since our dataset does not have any Boolean pairs or a column with the Boolean pairs, so we cannot see the output. Means where the yes or no values had been converted to true or false. But if you had a dataset with Boolean pairs, you can convert them easily to true and false by using true underscore values parameters and false underscore values parameter. Pandas read underscore CSV method is pretty smart. Whenever an entry in a CSV file has null, nan, or na, then read underscore CSV will interpret the value as missing. In fact, there is a full list of values that Pandas will recognize as missing, and you can read about them in the documentation. However, sometimes CSV files contain missing values in a subtle formats. Let's say in our superstore dataset, wherever 2 is there, 0 is there, and in segment consumer is there, as well as if there is a unit of 99 or 4 times 9, they are all, let's assume they are all missing values. How we can read a dataset and mention them as null values in place of these dummy values? First of all, let's see whether we have any missing data or not in our dataset. We have df underscore superstore. Now to see if df underscore superstore dataset has any missing value, we can check that by using this function. And you can see here postal code has 11 missing values. Otherwise, we do not have any missing values in our dataset. Now, as I had mentioned, let's assume that 0 to consumer, 99, 4 times 9, they are all missing values, but they had been imputed by a dummy values. What we want to do is we want to replace them with nulls, and later on we want to analyze and we want to use missing value imputation methodologies to impute them correctly and then use in our data analysis process. So what we are going to do is we are going to use na underscore values method. We are going to import superstore.csv file once again, and we are going to use na underscore values method, and we are going to pass the list of all the dummy values, which is 0 to consumer, 99, 4 times 9, and let's say 0 has also been saved as a string value. So we have passed 0 as a string also. Let's use the head method to see whether we had been able to replace all these values from a data set from a dummy value to null values. So in Pandas, null values are represented by nan. Let me print here df underscore superstore, showing you the first 5 records of df underscore superstore dataset by using head method. So you can see here consumer in segment variable we have consumer. Now in df underscore missing, when we pass 0 to consumer, 99, 4 times 9 and 0 as a string, and you can see here they had been replaced with nulls. Now you can see here for quantity and discount, wherever there the values were 2 and 0, they had been replaced with nan. Let's use the same function. For segment variable, we have now 5191 missing records. For quantity, there are 2402 missing records. For discount, it is 4798, and for profit, there are 65 missing data. And later on, we can use the imputation methodologies to impute them correctly in place of using the dummy values. Though Pandas infers the appropriate data type, it may become necessary to change them as some operation will only work with a specific data type. One can use the DateTime parameters and we can change the data type of any column while using the read underscore CSV method. Let's do an example. we are going to read Superstore CSV file. Let's say for any XYZ reason, we want to save order date and ship date as well as profit variable as a string. What we are going to do is we are going to use a DateTime parameter and then we will pass a dictionary. And then we are going to mention the variable name and their DateTime. And you can see here order date and ship date as well as profit had been saved as string data types. By default, Pandas will infer column names from the first line of the CSV file, but it is not always right. Let's look at this particular data set. If we are going to read this particular data set, Pandas automatically going to assign the first row as a header, but this is clearly incorrect. The actual data begins at index 2 as the first two rows are just gibberish. To fix this issue, we can use the header argument and assign the integer 2 to it. This will tell Pandas to promote the row at index location 2 as the headers. Let's do that example. As you can see here, since we have not used the header parameter, the data has not been read correctly. Now we are going to use the header parameter with the index location 2. By using the header parameter and mentioning the correct index position, we are able to read the data correctly. Today we have discussed some of the important parameters for importing CSV file in Pandas. I hope that you learned a few new things and that you will be able to use this in future data analysis project. In the next session, we are going to discuss how to import Excel file in Pandas. Till then, thank you so much. Have a great day.